hello. This time we're going to interview Mr. Stan Matwin from Canada. You did a really good presentation about big data in oceans, right?
That's right. That was big data meets big water.
Right.
That was the working title.
So the first question I noted is general, really general. We very often use term big data, but when it really starts counting as big, how big it should be to start it counting as
So that's a big discussion, and most of the time we try to avoid an answer which would be a number, so that 1 terabyte is big data and below it isn't. That's probably not a good approach. It's much better to understand it in a context of an organization, and the model I often use is that you have a company, a business, or a government unit that has some data that they generate or have to keep for regulatory reasons, for instance. And they also have a problem that they think they could address by using evidence from the data. So they can articulate this problem. They think they can help how they work if they could find answers to certain questions in the data. But they don't have the middle part, which is the how to do that. And the data would be big if, in their sense, it's too big to fit at once in their computing resources. So as you see, this answer will vary for different organizations. For some it may be even large gigabytes, for some it will be only petabytes. So you have these different units. It will depend who you're talking to, but that's the key thing. I think it's the value of the data and the fact that that the data can help you improve how you do your work as an organization is the key.
Okay, and in terms of managing the data and processing it, is there any difference between managing the big data and, I would say, the traditional size of data?
Yes, there is, and this is something we experience in our oceans data work. And it's simply the fact that if you throw this really big data at the standard database management system, for instance, then you can perhaps fit it, but it's really not possible to answer any interesting queries in reasonable time. So you can put it in a database, but then you ask a very standard question that in a normal, regular size of data you could get an answer to in a fraction of a second, but because of the fact that data is big and has to be organized differently in multi-level indexing, for instance, and so on, it may take you literally minutes before you get an answer in a standard, quite efficient database management tool. So, of course, this isn't really often acceptable in a business or management practice, and that's why you need to seek other solutions with big data more often than not.
Okay. Well, you presented results of research that, well, with the help of analyzing data, big data, describing position of vessels, various vessels, including fishing vessels, you can, I would say, maybe improve routes for fishing according, I would say, the ecosystem, or taking, including, well, maybe the quality of the ecosystem.
That's correct. Yes.
So this is one side, and I would say, is it possible on the basis of the same AIS data to for instance, detect that the vessel was hijacked, or that there is some other serious issue with the vessel, despite it's not, there is no Mayday yet?
That's right, yes. So indeed, I mean, there is this option. It will simply depend on how is the vessel behaving. And so we have a set of techniques and algorithms that detect anomalies in data. And then what you do is you look, for instance, at a tanker, and you know that the normal trajectory of a tanker has a certain geometry and a certain dynamics in terms of speed of the vessel along the geometry. And you can also detect that a particular tanker moves in a way which is quite divert from this standard way. And this is perhaps a signal for you that there could be a problem. You couldn't have known, most likely, whether the ship was hijacked or is it experiencing technical problems. But it would be sufficient to flag that vessel as a concern for whatever authorities you have in a given area to inquire, perhaps go to another data set like optical satellite data to see an image of the ship, perhaps to fly an aircraft over it, perhaps to look for an explanation, because maybe there's a very benign explanation. The ship has slowed down because there is a severe weather system in front. So there's another of options at that point to investigate. But the main point is that the techniques that we have can open the door and kind of allow you to catch that potential risk in a whole mass of ships that move around.
Right, so it sounds like a little bit of opening the door to somehow fighting the seas piracy too.
That is certainly true, and these technologies have been used in that role very much in the recent past. Of course, the issue is that the pirates now know about it, so one of the first things they would do is turn it off. But if you were fortunate enough to know that there is a problem, if you can then transfer to radar technology, satellite radar technology, you can follow the ship at least, and that's what's being done. So, yes, technology starts to be a tool by which you can monitor and follow a ship and detect problems in these security adverse situations.
Okay, maybe monitoring ships is not the only solution of this kind, right? Something very, very similar is connected with planes, right?
Yes, of course.
Is it based on pretty much the same model, or rather, could you use your solution?
We could indeed, and there are planes, and I mean commercially flying aircraft that are equipped with AIS emitters, and you can follow them, and there are even websites that will allow you to do this. So it's entirely possible. The issue is that I think, unlike in the ship area, where there is a kind of a regulation of the International Maritime Organization that every ship must carry that type of device, the airline world is much less technologically advanced, and I don't think they actually require of all aircraft to have these types of devices. So some may, and some may not, simply because they're concerned with the cost, and it's very difficult to regulate this. But I think once we get a hold of the solution for the cost, and the cost, I've seen some estimates to universally install that type of technology on aircraft to be able to totally follow in a kind of relatively error-proof way all the aircraft around the world. It would be currently at the level of $2,000 to $3,000 per flight. So if you divide that, you have about $10 per passenger per flight. So it's not entirely impossible to imagine that such solutions could be instituted. And then, the sad cases of, let's say, the recent Malaysian airline incident, where the aircraft has essentially disappeared and nobody knows what happened to it and where it went, would simply be impossible.
It looks like that those methods, that research is very, very universal, and in a few years, I think, maybe 10, 15 years, the scope of utilization will grow rapidly. How do you think?
I agree. I think there's a potential to see these methods infiltrating other areas of human mobility in the cities, for instance, human mobility on highways and in large gatherings of people and so on and so forth. And that would be really interesting because I think it would allow us to work out better solutions for some special cases. For instance, if you look at a busy street in a city in the summer, you can, using these methods, detect how many people walk, how many people cycle, how many people take a bus, and how many people drive. And depending on that information, you can design the road so that you will accommodate all these kinds of traffic and maybe promote some in terms of bicycle lanes or public transportation in certain hours, because you will know when and how people move. So this is really very much futuristic. I think one issue that we have to be careful about and think when we will be designing and subsequently implementing such systems are all the issues concerning privacy of individuals. Exactly. And this is very important. This is something that we, I think, need to think about and kind of build into the design of these systems from step one, using this approach of privacy by design and some sort of art cutting-edge techniques, state-of-the-art, to make it impossible to track one individual in a mass of others with some, knowledge of their patterns of movement. So I really wanted to bring a word of caution here and not be just sort of one-sided on the technology side. Yes, there are many possibilities. We just have to be mindful of the downsides as any technology may have. In that particular case, it's the privacy concerns that need to be very much in our mind when we work on these systems.
Yeah, exactly. Because it's going to be like implementing, rather building another Facebook, just that dozens of times bigger and more powerful.
And very knowledgeable also. It would know what you're doing, what time of the day, regardless of the fact that whether you want it or not, so to speak. So we have to think about preventing very unpleasant situations where people can be tracked down and perhaps information can be collected about them in a way which is really not serving the original purpose of the system, but violating certain basic human privacy rights. And it's not easy to do to kind of enforce these types of regard for human privacy in these systems, but we very much need to think about this. And part of my work is also to work on solutions in this area, particularly concerning human mobility data and privacy.
Okay, so thank you.
Thank you.